Okay, today we're learning about section 10.3, linear regression hypothesis testing, or in other words, the Lin-Reg-T test. Okay, so our null and alternative hypotheses for this type of test can be worded a couple different ways. We're going to stick with words rather than symbols for this particular test. So we're going to say for our null hypothesis that there's no correlation between the two variables. Another way to word that would be there's no relationship between the variables. And then the alternative hypothesis is that there is a correlation between the variables, or in other words, there is a relationship between the variables. These will never be reversed. So the no correlation will always be the null, and the correlation will always be the alternative. There are some symbols that you could use for these instead, and your book does go into some detail on using those symbols for the null and alternative. But for our purposes, we're just going to be sticking with the words. All right, we are back to the T-chart to find critical values for the linear regression test. However, one major difference, the degree of freedom is found by taking the sample size minus 2. In other words, if there are 7 points on your graph, you're going to take 7 minus 2 to get 5 degrees of freedom. All right, so here's the first example that we're going to go through together. It says, do the number of absences seem to influence final grade in the class? Test the correlation using an alpha value of 0.05. Okay, so for our null hypothesis, we would say there's no correlation between absences and grade. And then for the alternative hypothesis, we would say there is a correlation between those two variables. So there is a correlation between the number of absences and the final grade. Okay, so that's step number 1 of our hypothesis test. Step number 2, we have to find the critical value. So we're on the T-chart. When we're testing a correlation, it could be a positive correlation or a negative correlation. So we're going to shade both tails for every single test that we're going to be doing for linear regression. It's always going to be a two-tailed test. Our degree of freedom is the number of points minus 2. So taking a look, if I were to graph this, 1, 2, 3, 4, 5, 6, there would be 6 points on my scatter plot. So I'm going to take 6 minus 2, and that's going to give me 4 degrees of freedom. The alpha level was given in the prompt as 0.05. If it is not given in the prompt, remember that 0.05 is our default alpha, and we need to make sure that we're looking for that in the two-tailed section of the chart. So taking a look at the T-chart, degree of freedom of 4 with an alpha of 0.05. Degree of freedom 4, an alpha of 0.05 in the two-tailed section. It looks like 2.776 is my critical value. So 2.776. Now again, that would be the positive value on the right, the negative values there on the left. So I'm going to say it's positive or negative 2.776. So those are my critical values. Okay, guys, I'm going to go ahead and enter these data points into my calculator and ask the calculator to come up with the test statistic and the p-value, which we will use to make our decision and summarize. So number of absences are going to go into list 1, and final grade is going to go into list 2. Okay, I've entered those values into list 1 and list 2. I'm going to go to Stat, over to Tests, and select the LinReg t-test, which is letter F in my calculator. The X list is list 1, the Y list is list 2. We're going to keep that frequency at 1. We select the not equal to case. We could store the regression equation. I went over how to do that in the last video. That is optional. You can leave that blank if you do not want to store the regression equation in your Y1. And then click Calculate. Okay. Step number 3, the test statistic. That is the t equals value that we see in the calculator. So step number 3, the test statistic, t equals negative 3.797. The p-value is the next value that we see in the calculator. So the p-value is that 0.0192. 0.0192. Okay, and to make our decision, we're going to compare that p-value to the alpha. So if I look here, p is 0.0192, the alpha value is 0.05. P is less than alpha. When p is low, we reject the hoe. So if we're rejecting the null hypothesis, that means that we are saying that there does seem to be a correlation between the number of absences and the final grade in the class. Okay, here's the you try example. Are the number of assists in the NFL correlated to the number of points scored in a game? A random sample of games were collected to analyze this. Use an alpha of 0.05 to test the correlation. Okay, guys, pause the video, see if you can go through those 6 steps for hypothesis testing for this linear regression example. Unpause the video to then get the results. Okay, here are the results of that example. Our null hypothesis, again, is no correlation between the two variables, so no correlation between the number of assists and the total points scored. And then the alternative hypothesis is that there is a correlation between the number of assists and the total points scored. Step number 2, the critical value came out to be positive or negative 3.182. That has degree of freedom 3, alpha value of 0.05, and it's a two-tailed test. Plug those values into the calculator, stat edit, number of assists went into list 1, and total points scored in list 2. I went to stat, over to tests, and selected the LinReg t-test. Same settings as the last, list 1 for X, list 2 for Y, frequency of 1, the not equal to case, and calculate. We got the t-value, the t-test statistic, as 0.11, the p-value as 0.9185. P is greater than alpha here, so P is not low, so we do not reject the hoe. If we're not rejecting the null hypothesis, we are saying there is no correlation between the number of assists and the total points scored in the NFL. All right, guys, that concludes the notes for today. Post any questions in the discussion and submit that assignment.